Good afternoon, everyone. I hope you had a good lunch.
First, we can check maybe
Yeah.
are they able to hear
Are
us
you able
or
to
not?
hear us properly, loud and clear? Thank you. Thank you for confirmation. So, my name is Anand. I am a senior specialist partner solution architect for enterprise transformation, and I am joined by here with Nishan. Nishan, over to you.
Hi everyone, very good afternoon. Thank you for ensuring your time over here. My name is Nishan Dhiman. I'm a senior solutions architect at AWS. I'm based in Sydney, Australia. We have got a power-packed content for all of you. Stay tuned. We'll get started with covering the best practices of SaaS architectures on serverless.
Thank you, Nishan. So, just a quick poll. How many of you are already using the software as a service model? Okay, quite a few. Great to see that. And how many of you are already familiarized with the serverless and also using the serverless to implement the software as a service based model? Oh, nice. Cool. So, let's get started. Many of our customers are adopting the software as a service and the multi-tenancy based business and the software delivery model, right, to expose and deliver their products and capabilities in the service centric manner. This helps them to accelerate their business growth, also optimize the cost and the operational efficiency, at the same time also help them to innovate faster. The serverless is become the obvious choice to implement the software as a service and the multi-tenant architectures on cloud on AWS. But when we talk about the multi-tenant architectures, they have their own challenges, they have their own considerations, and it requires a careful design and the architectural considerations when we build multi-tenant architectures. Today, we are going to cover some of the best practices as well as the design consideration and the architectural consideration which we should keep in mind when we are building those multi-tenant architectures. So, just quickly to run through the agenda, we will be looking upon some of the multi-tenant challenges. Then we will be looking upon the serverless capabilities and how serverless help us to build those multi-tenant solutions on AWS. And then we will be having a use case throughout this session, and that use case we will put a SaaS lens as well as the multi-tenant lens to understand and uncover some of these challenges with the right design and the architectural considerations, and we will follow along with the different best practices we should adhere to when we are building those solutions. So, what are some of the unique challenges when we build the multi-tenant architectures? The first most is definitely around the tenant isolations, because during the multi-tenant architectures, we definitely do not want one tenant data is getting exposed to the other tenant, because that can have a severe consequences to the reputation of the business. The second challenge is around the noisy neighbor, right, where the activities performed by one tenant may significantly have an impact to the activities from the other tenant, right, and that can have a bad user experience for the different tenants. The cost attribution, because when the customers are building the multi-tenant solutions, they definitely want to optimize the cost, and one of the way of optimizing the cost is also provisioning the resources which are required enough to adhere to the tenant's demand or the tenant's need. At the same time, how can they identify the consumption and the cost for those different tenants so that they can charge them accordingly, and that can attribute to their business growth. The next one is insufficient resource utilization, where the customer, they do not want to over provision or under provision the resources, right, for the multi-tenant applications, right, and because that will have a direct proportional impact on the cost as well as the user experience what they want to deliver to their end customers. Last but not the least, the scaling integration. Often the time we always focus on the business logic, the databases and the infrastructure based components when we are considering the multi-tenant architectures, but when we are talking about the software as a service model, we are essentially talking about the complex distributed systems, because we are talking about the service based architectures, And the service-based architectures definitely requires a lot of integrations, and this integration component often the time get unattended. And today we are also going to cover what are some of the best practices and the design considerations for the multi-tenant solutions when we talk about the communication between the different architectural component for those SaaS-based applications patterns. So, okay, so far we have understood the challenges. Now, why the serverless become one of the obvious choice to build the multi-tenant solutions on AWS, right? If we look upon this graph, the solid line, the blue line actually represent the true tenant behavior in the multi-tenant environment, because each tenant is different. Each tenant have got their own scaling, behavioral and the consumption patterns, and that's the reason that introduce a lot of variability in the multi-tenant application environment. What we see on the dotted line is the ideal spot where the customer want to be in, because they want to provision the resources along with the behavioral pattern, the consumption pattern of those different tenants, so that they can have a right cost, scale and the performance. At the same time, they do not pay extra, as well as they provide the right user experience without compromising the business features. And the narrower the gap between the solid line and the dotted line, better the agility, better the operational efficiency, better the cost optimization for any multi-tenant architectures. And that is where the serverless comes and help us, because with serverless there are no infrastructure to manage. So the undifferentiated heavy lifting which otherwise the customers have to do to build the multi-tenant architectures go away with the serverless, with the adoption of the serverless based approach. Serverless based architecture auto scale, right? So based on the tenants consumption patterns, based on the tenants traffic and the throughput pattern, the serverless based architecture will auto scale, and there is no hourly charges, there is no dedicated provisioning of the resources. So we do not pay for what we are not utilizing for. We only use the pay as you go model, where we are paying for what we are consuming with the serverless based architectures. And last but not the least, the serverless based architectures and the serverless services are highly available and scalable, right? So let's quickly talk about what are the different multi-tenant model, and then we will work backward throughout this session to uncover some of the best design and architectural practices to solve some of those key challenges which we saw in the beginning of the session. The very first one is silo. It is quite common one. There is no brainer here. It's like each tenant we are provisioning a different resources. It's a very easy architectural choice. You just deploy the resources per tenant basis. The advantage you have is it's easy. You get a better data isolation, but often when the number of tenants are increasing in your environment, this particular architecture which initially look easy, over the period of time grow complex, because if the tenants are increasing, your number of resources in the environments are increasing, means your operational overheads are increasing. At the same time, your cost is also increasing for those different environments which you are provisioning for your tenant. The next model is pool model, where instead of provisioning the resources dedicated to the individual tenants, we share the resources across the tenant, and we leverage and harness the power of the cloud to scale and to meet the different tenants, different consumption and scaling and the traffic patterns. This provides us a better operational efficiency, at the same time better cost management, but it also comes with the consideration of proper data isolation. So for most of the customers, they want to be in this state where they leverage the pool model, so that they gain better operational efficiency, at the same time better cost optimization. But what we acknowledge and what we have observed, there is no single size fit for all the problems, and what we often observe is the combination of both of these models, the silo and the pool, where some of the architectural component we provision dedicated to per tenant. At the same time, some of the architectural component get shared across the tenant, and that is nothing but the bridge model. Now, for the rest of the session, we are going to focus on the pool model, because that is the model which takes us to the more better cost efficiency, at the same time the operational efficiency. And wherever we will be referring to the silo or bridge, we will be explicitly highlighting that. Now, to understand the different design and architectural considerations to mitigate some of the multi-tenant challenges, we are going to iterate through the hypothetical use case of a B2B SaaS based platform for e-com retail businesses. This platform allows the different retailers to get on board so that they can expose their business capabilities on this e-com platform. Retailers of different size can get onboarded to this B2B SaaS platform. It's like a Shopify, where you can onboard your business quickly and then expose to your end users. We have taken an order management workflow for our session today. The order management workflow will have two subtasks. One is the order creation, where it is leveraged by the couple of bunch of services, order service and the product service, which help the end users to identify or browse the product and then place the order accordingly. And then we also have the second part of it, which is the order fulfillment and the shipment, where once the order is placed, the bunch of services like fulfillment service, invoice service and the shipment service come together for the fulfillment of this order. And these two paths for the order management get the interaction done with the decoupled event driven architectures. So now let's focus on the first path of order management, the order creation. The order creation, which considered the product service and the order service. If we have to implement this particular path using the serverless based architecture on AWS, the story looks fairly simple. You will have a Lambda function. I hope we all are aware of the Lambda functions, which is a serverless compute, where it allows us to focus on just writing a business logic and then run those business logic on the cloud without worrying on the undifferentiated infrastructure management. Right. So let's say the Lambda represent the order service and the product service for the order creation path, and then these services get exposed to the end users via API gateway, which is the another service, serverless service which we have, which allow us to expose these service capabilities to the end users. And then we have a database which store these orders, and once the order is done, it emit the event that order is created to the rest of the architectural component, to the second path, which is on the fulfillment side. Now envision this particular architecture with the pool model, where we have a common Lambda functions which get invoked by the different tenants who are getting onboarded to our B2B e-com platform. Now, so what are the architectural consideration we should have with the multi-tenancy for Lambda function? What we discussed when we were talking about the multi-tenancy challenges, the very first challenge is around the data isolation. Now let's try to understand the data isolation architectural consideration with Lambda functions. So what are the different deployment model of Lambda which are possible? The three deployment model what we saw, the silo, pool and bridge, they all are possible. For example, our order and product service, we can deploy it into the pooled model, where multiple tenants are actually executing the Lambda functions, the common Lambda function. We can also deploy these Lambda function dedicated to the respective tenant, which will become the silo model, right? There could be a different tiering strategies for the multi-tenant architecture in which these the deployments can be done. And the last but not the least, you can have the CI/CD pipeline to deploy all of these the Lambda based architectural components. So now let's talk about the data isolation. Now before even talking about the architectural consideration for the data isolation, let's just have a look on how traditionally the data isolation is done. for the multi-tenancy solutions. The user get authenticated. There could be IDP who does that authentication. For example, on AWS we have a Cognito. Once the authentication is done, then that bearer token is returned back to the user, and the user or use this bearer token and invoke the different services. In our case, let us say it is the product and order service. It is received by the API gateway. The gateway level we do the authorization check, because this is one of the best practice where we are offloading the cross-cutting concerns like authorization at the gateway layer rather than taking the end layer service like product and order is taking care of the authorization. Once the authorization is done, then the endpoint means the backend logic is executed. In the multi-tenancy scenarios, each tenant would have their own authorization considerations based on their requirements, business requirements and the regulatory requirements. Often what we have seen, these authorization logic is actually configured with the role-based access, where the business logic will have understanding what resources it should have access, or the attribute based access where the tenants require the more granular access controls for those resources. And all of this authorization logic with role based access and the attribute access get coded or get tagged along within the business logic itself, and that pollute the business logic over the period of time as and when the different tenants requirements around the authorization get complicated and the complex. And one of the standard recommendation is getting away all these cross cutting concerns from the service, because your service should only do what is differentiated for your business. It should only contain the business logic. It should not contain any other cross cutting concerns like authorization rules and the validations. So one of the recommendation is externalize these complex authorizations logic away from your core business logic. And how we can do it? We can do it via an external policy store, and that external policy store is nothing but Amazon verified permission, which allow us to configure the role based access control and attribute based access control away from your business logic in a more declarative way, where you are not coding those role based and access based complex authorizations rule within the business logic. Instead, you are using a declarative approach to define those role based and access based authorization policies. And what happens when the user make a request to the application reach out to the verified permission will have all the policy stores configured according to the tenant's need, along with their role based access and the attribute based access control. And the verified permission dynamically will verify the different access permission, whether the permissions are allowed or denied, and then the access decision will be returned back to the application, right. And with this you can define a better, more governed data isolation policies amongst the different tenant in the multi-tenancy architectures, right. So how the declarative policy looks like? So the CEDAR is one of the policy language which is often used for defining those declarative policies. So if you see the sample here, this is the the sample policy which looks like which is defined with the CEDAR policy language, and it has a multiple part of it. First thing, okay, what it allow, what it permit this principal could be end user or a role. So this role will have a different actions which are permitted, for example create or view order, and on what resources, as well as these different attributes which define the more granular controls, like if the principal is in the context of the same tenancy, as well as the principal account is not locked, as well as it is using the multi-factor authentication, then only allow them to create or view order. So this is how we can combine the role based access and the attribute based access via this declarative CEDAR policy language, and then this policy can get stored by the Amazon verified permission, and that can be dynamically accessed by the pooled based microservices what we are building for our multi-tenant application. And based on the tenant ID which get injected dynamically, these policies can have their own effect. So, how it looks like in the implementation? So, different tenants accessing the common pooled microservice order or product in our use case, right. Each user is having their own tenancy context, like for example tenant 1 and tenant 2. If each tenant is having their own complex authorization requirements, then we can define the different policy store for each of these tenants. Still our application logic remains the pool, the Lambda is still a pool model, but it is having, there are different policy store which are defined by the Amazon verified permission for the different tenants, and dynamically our pooled microservice, which is the Lambda, based on the tenancy context, can identify which particular policy store has been configured within the Amazon verified permission for that tenant, and accordingly those policy get evaluated, and then their access permissions results are written back to the upstream system. There could be another scenario where the multi-tenants are having a common or similar authorization requirement. They do not have any peculiar or the complex authorization requirement. So, we can have a pooled concept for the Amazon verified permission as well, where we have a pooled service layer Lambda, and once the request is received by this Lambda function for the different tenants, there could be a one verified permission policy store with the one policy which get dynamically evaluated for the different tenants as well. With this we arrive to the, we can help, this particular model can help us to achieve the tenant isolation, which was our first challenge what we observed for multi-tenant solution. Now let us look into the next challenge, what is around the, how do we determine the cost per tenant in the multi-tenancy architectures. So, when we have to identify the cost for the respective tenants, what are the different ways in which it need to be arrived. So, to arrive the right cost, what is important is to identify what are the different actions which are being taken by each tenant in our environment for that particular SaaS multi-tenant application. At the same time, for each of those actions which are being taken by the tenant, what are the resource consumptions? What are the actions which has been taken by the tenant can get compiled via application log, and for as part of each action, what are the resource consumption that can be compiled over the different utilization metrics on the cloud. Now, we have order service and product service. This application logging and the resource utilization consumption matrix is applicable for both of these services, not only these two services, but rest of the services as well as part of our e-com. One of the other recommendation architectural pattern is to do not duplicate the code, and that is where we need to again externalize this particular configuration as well to arrive to the application logs to determine the action as well as the resource consumptions matrix. And we have an option called Lambda layers. What is Lambda layer? Lambda layer are the mechanism within the Lambda functions which allow us to share the code across the Lambda function, so that we do not increase the size of the Lambda function, at the same time we share the different common libraries and the configurations across the Lambda function. Now, what we can do to identify what actions the tenants are taking, the application logging, and for those actions what are the resource consumption, we can compile using the matrix and the logging Lambda layers, and these logging and matrix Lambda layer can leverage the another Lambda layer which allow us to decode the token which is coming as part of the each request, which contain the identity context for that particular tenant. So, how the flow works? The request is received by the service layer, the service layer reach out to the Lambda layer then decode the token, identify the right tenant context, and then it logs the application behaviors as well as the consumption metrics, right. So, how architecturally it looks like? So, for example, we want to capture the metrics for API gateway, where how many number of requests has been served for respective tenants, or even for Lambda, how many number of Lambda invocation has happened and for what duration. This will give us a right fair understanding of what is the cost consumption for respective tenants. So how it will be architecturally built? So tenant users are making a call with their respective tokens to the API gateway. From API gateway, the authorization is done. After the authorization is done, the request is then control is given to the service layer, which is our product or order service, and then this particular service layer reach out to the Lambda layers, where the Lambda layer go and push the different application logs and the consumption metrics to the CloudWatch log, and with the proper tenant context, which is represented by nothing but the tenant ID. So if you can see over here, this is how the typical application log look like, where it has a tenant ID context injected into it. So with this kind of mechanism, we can identify the different tenant consumptions and the actions taken within the SaaS or multi-tenant environment, and then we can arrive the cost accordingly. And this particular concept help us to achieve the cost per tenant. The next one is the noisy neighbor, right? So the typical SaaS based model adopt the tiering strategy as well as the throttling strategy to make sure the one tenant does not impact the behaviors of the other tenant, right? And one of the mechanisms to build those tiering strategy as well as those throttling strategy is leveraging the Amazon API gateways usage keys pattern, where you can build a usage plan which will give you the respective keys, which can be shared to the different tiering bound tenants, tiering strategy bound tenants, and those particular usage plan keys will then evaluate the different throttling configurations which can be done for the respective tenants in terms of the number of requests they can send for that multi-tenant application, right? So this is how the overall implementation look like, where we have a API gateway, it is configured with the usage plan key, and then those usage plan key can be configured with the different tiering strategies, and then the different microservices layer at the end will get throttled at the gateway layer itself based on those configurations. So the tiering strategy is good, but what if the premium tier tenant need to have a dedicated capacity, so that the charges what they are paying to that multi-tenancy application provider, they also make sure they have a right capacity always available and it is not impacted by the other tier tenants in the environment. Now, if it is a traditional EC2 compute or a container compute, then one of the option could be you have a dedicated cluster of EC2 and then have a auto scaling configure for those premium tier customers or tenant, or you can have a dedicated container cluster provision for those premium tier tenants. But when we talk about the serverless Lambda, the concept here is serverless, where it does not give a direct handle for the infrastructure. Now in this case, how do we make sure our premium tier tenants are always having the capacity, so that they do not, their end user does not face any bad service experience? And that is where we will have to look upon some of the concurrency strategies which Lambda provide to mitigate the noisy neighbor situations. So Lambda has two concepts. One is account concurrency, which talk about how many number of concurrent Lambda function can get executed at any given point of time. The default limit is 1000, but it can get increased. The other is the functional quota, which talk about that what rate the Lambda function can get scaled. So which is the 1000 new concurrent Lambda function for the individual Lambda functions every 10 seconds, right? And this limit cannot be increased. So what if you need more scale? Let's say one of your premium tier customer is actually having a very large user base and they need further more scaling needs apart from what out of the box Lambda provide, the 1000 Lambda function scale per 10 seconds. And that is where we have something called the provision concurrency, where in advance we can pre-warm the Lambda function and we can configure the Lambda function along with the out of the box Lambda scaling capability what we have, which is 1000 per 10 seconds. And this will allow to take care the any other further scaling needs which any of the premium tier customer may have in the multi-tenancy scenario. Right. But what if we are able to scale the Lambda functions as per the tenant's patterns need and the throughput need, but what about the downstream system? For example, if we are able to scale the Lambda to 1000 Lambda functions per second, but what if the number of database connections are not available to handle all those requests? And that is where we also have something called reserve concurrency, which takes care of how many number of concurrent execution can happen to the respective Lambda functions. And this particular reserve concurrency control will help us to define those controls for throttling, which will help us to avoid the noisy neighbor situations for Lambda based architecture. So, how it works? We can configure this reserve concurrency. For example, if I configure reserve concurrency of 300 for advanced tier tenants, then the advanced tier tenant will be having the 300 execution of the Lambda function, not more than that. Post that, the request will get throttled, and remaining reserve concurrency can be then dedicated to the platinum customer, so that they make sure that those particular capacity is always available with those platinum customers. So, the combination of reserve concurrency and the provision concurrency can help us to mitigate the noisy neighbors situation along with the usage plan keys for serverless based multi-tenant architectures, right. So, just the key takeaway with the Lambda functions, the architectural considerations: use Amazon verified permission to externalize the authorization logic and do not pollute your business logic. Control the noisy neighbor situation using the reserve concurrency as well as the API gateway usage plan, and then leverage the Lambda layers, right, to have the proper logging and metrics consumptions, right, again externalizing from the business logic and arrive to the right cost per tenant. Now, with that, let us try to understand what are the different architectural and design considerations for the integrations within the multi-tenant architecture, and for that I would like to invite my co-speaker Nishant. Nishant, over to you.
Thanks Anand. I hope I am audible. Perfect, thank you. All right, so how many of you use microservices to host SaaS based applications? Please show me your raise of hand. At least if I am given a choice as a customer or as a user, which one do I need to pick to host my SaaS based application today, I would definitely go with microservices. Why? Because of non-benefits like independent scaling, better resource utilization, as well as easy deployment. So, it definitely puts us on the ease of operational excellence. So, that is why we use microservices. But question in front of us is, how do we make them communicate to each other? Let us dive deeper into some of the popular integration patterns which customers use to host the SaaS based applications on microservices powered architectures. First one is synchronous. Sender sends a request to the receiver, receiver processes the request, and until the duration receiver is processing the request, sender is waiting. But what if receiver fails? Sender has to retry the request himself or itself, right? And what if receiver has some dependency on the downstream services? It again has to wait. So, to circumvent these challenges, we have another popular pattern called asynchronous, where we are introducing some intermediate party between the sender and receiver, where sender is putting the message into the queue, which is acting as a buffer, and it gets an acknowledgement, okay, I received the message and I will pass it on. Receiver will poll the message and your work is done, and then 202, and sender will receive the message once the receiver is done with his work. Last one is publish and subscribe, where publisher sends a message to multiple targets, interested parties, by having some routing logics. It works on the push based mechanism, unlike the poll based mechanism in the second architecture, which is the asynchronous one. Okay, so I am carrying forward to the first half of the architecture to the second half. We saw the product service, we saw the order service, and if we extend our architecture a bit further to fulfillment as well as shipment service, this is one of the possible implementation. where in fulfillment service you may need to create some pick list, give the acknowledgement, okay, now order can be packed. So, order created event is received, and on the event bridge it is passing on to the SQS queue, where Lambda is going to poll the messages from SQS, going to pass that event that, hey, now order can be shipped. Ship order events is created and it is passed to the different service called shipment service, where it has its own workflow implemented through step functions maybe. But the common questions when it comes to SQS we receive from the customers are, hey, should I share my queue across the different resources, or what if one tenant produces more messages than the other? What about operational complexity? What about error handling, right? And what about data isolation? Very important. We will gradually address all of these challenges. Let us first look at noisy neighbor situation. You can see in the slide, tenant A is having more messages as compared to 2 different tenants. What if your tenant C belongs to premium tier? You want to prioritize the messages from tenant C because they are from premium tier. So, tenant C in this case has to wait until all the messages which are ahead in the queue should get processed. Customers want to avoid such scenarios, solve these challenges by staying cost efficient, and they also want to ensure that data is completely isolated as per the tenants. How do they achieve it? There are a few mechanisms which we are going to walk you through. What they can do is, if you have configured your tenants into tiers, you can have separate queues based upon the tenant's tiers. For example, from the standard tier, let us say if your tenant A and tenant B belong to standard tier, you can have one separate queue for them, and if your tenant C belongs to premium tier, you can have a separate queue, and then the messages can be processed. At least more messages from the standard queue or standard tier are not able to intervene the messages which are supposed to be processed on priority for tenant C, which are premium tier. What about handling the noisy neighbor with rate limit? One of the popular mechanisms which our customers leverage today is the implementing the rate limit at as close as to the sender. For example, you are receiving multiple messages like create order from different tenants within microservices. Hey, create order from tenant 1, create order from tenant 2. You can have a mechanism implemented within a microservice. I am going to check the throttle, whether how many requests per second are allowed for that particular tenant, right? You can process that and then put the messages into the queue. It will help you to not overload your queue with lot of messages, right? If you are using something like API gateway usage plans, you can associate your tiers, standard, premium, gold, or any sort of tier with your usage plans with API gateway. There you can define, okay, 300 requests per second is allowed for gold tier, and standard tier of course has lower requests per second rate. All right, how many of you have configured SQS with Lambda functions? All right, many of you. So, when we configure SQS with Lambda functions, there is some attribute called batch size. Batch size is nothing but the number of messages going to be there in one invocation. By default, that batch size is 10. But what if in that batch size, it is highly possible that we can receive messages from different tenants in that batch size, and if you get the wires crossed within your code, or there is something wrong, or there is bug in your code, then you may end up having your one tenant accessing the data of other tenants. We should avoid that. How we can avoid that? By configuring the batch size. So, in this case, if batch size is 10, by default you will receive these all the messages getting processed in within one invocation. And if you configure the batch size as 1, you can exactly end up having one message in each batch. It means one invocation will receive exactly one message which will belong to one particular tenant. There is one downside of this approach. For example, if you have multiple tenants and if you have more messages, it will create backlog in your queue. It is applicable if you have smaller tenants or small number of messages, then you may implement this approach. All right, what about data isolation and security? So we put our messages in SQS, and SQS comes with a default out of the box feature which is called resource based policy, which allows senders who can write the messages, who can send the messages into the queue, and then these messages are getting processed. But there is another feature which you can use, which SQS offers, is message attributes. It is helping you separate your data isolation logic from your business logic. If you see, there are message attributes as a parameter, and there is message body which will carry the content of your message. And if you need to configure the message attributes to carry the tenant ID or tenant tier as the tenant context, so that your downstream services can access those contexts, and it will remain same throughout your message in the journey until it is written into the very last component of your architecture. Let us talk about some of the best practices that we have got for SQS. We have different tenants in multi-tenant architectures: gold, platinum, standard, but it is great if we can leverage the delay queue feature of SQS. If you are sending some message to the SQS, you have an attribute called delay in seconds while sending the message. Send message, it will have a key which you can configure delay in seconds as per the message. If that message belongs to the premium tier, then you can configure that delay very short, or maybe you want to keep it 0. But for sender tier, you can additionally intentionally add the delay. In-flight messages, we should definitely avoid them, right? In-flight messages are those your receiver picked them up, but they are not deleting that messages from your queue. And if your message is not getting deleted from the queue, it means it is creating the backlog in the queue, right? So ensure that your receiver or consumer is deleting the messages after processing. Use dead letter queue for messages that cannot be processed. Your receiver ends up in the error, in some error because of some issue, and how many times receiver failed while processing the message, you can configure that parameter message receive count at the SQS, that hey, how many times your message is back in the queue, it was not processed from the receiver. Then you can put that message into a separate queue which will be your dead letter queue to analyze, okay, what's wrong with your application. Last, you can consider passing the tenant context by leveraging the message attributes feature when your SQS queue is getting shared across tenants. Cool. How many of you came here by air? At least I flew from Sydney, Australia. Most of you. And while approaching the baggage handling team, of course, you come with your check-in baggage. You dropped your baggage at baggage handling team, and they didn't ask you to wait until your bags are shipped to the aircraft. Instead they said, okay, I received your bag, you can proceed towards security. And if they would have asked you to wait until your bag is shipped to your aircraft, you might have missed your flight, right? In that case, similarly, what they did, they just created an event in their system, baggage dropped, and then they did let you proceed towards the security. Similarly, we are using event-driven architectures in SaaS-based applications. In the order creation, we are receiving the order created event, and these events are getting routed to different targets, the meaningful targets based upon the events. No party is waiting for the second party. It's like the response is getting processed, and once it's done with the processing, they are letting the service know, okay, we are done with our work, here is the message. Let's see what is powering that architecture. It's the Event Bridge rules. Event Bridge is the serverless fully managed AWS service, which is a serverless event bus, which helps you route your events to different targets based upon the event matching pattern, which is nothing, just a logic that you write in the rules. There is a match, then the event will be mapped to the targets. But oftentimes customers ask, hey, should I have different rules or separate rule for tenants, or should I use the same rule for all the tenants? It depends. It depends. If you are having, let's talk about this example. You are having that example, that event example from the order service. Here is the event, and you have that tier, that message belongs to the gold tier, and then the tenant ID is something like some unique ID, and then the event bridge rule, you can configure it to be, matching the events based upon the tiers. You are configuring that, okay, now it belongs to the gold message, and then the event can be processed and routed to the fulfillment service. If your tenants have same routing and processing logic, you can combine them into one rule. You can have one rule per multiple tenants. But if you have different tenants and they require different routing and processing logic, it's great to have separate rule for each tenants. But in most of the cases, shared rules will work. Let's optimize the number of rules. Over time, when we proceed, when serverless or SaaS based applications grow, we see the increase in number of tenants, and over the time they tend to become really complex, right? Because your number of rules will increase, your number of resources will increase, limits will meet, right? You will request the limits and whatnot. Let's take an example. There is an event from tenant A. There is some error from the shopping cart service that, hey, there is a timeout error. There is an event from tenant B. It's some error from different microservice, which is maybe inventory, it got out of stock. What's common between these two events is error. Still our architecture grew, our SaaS based platform or business grew, but we can definitely identify the scope of optimization by identifying common patterns where we can use same rules. To use the same rules, there is out of the box feature which is supported by Event Bridge called wildcard pattern matching. In wildcard pattern matching, you define, okay, there are events from the different tenants, there are errors. In this example, maybe you want to process, or you want to pass all those errored message into a single CloudWatch log group, right? In that case, error message from different tenants and microservices are going into a single CloudWatch log group. Why? Because you have configured the event bridge rule with the help of wildcard pattern matching. For example, if you see star.error.star, it's the wildcard. Every message that has the error inside it, based upon that rule matching mechanism, pattern matching mechanism, it's going to get routed to the, maybe you want to raise an incident if there is any error in your SaaS based app, or maybe you want to send the messages to a single CloudWatch log group to analyze what's wrong with your SaaS based app. And when you do that, you are promoting operational excellence, you are reducing the rule management. In some cases, you want to have a dedicated event bus, but in some cases you want to have a shared event bus. There are few components, maybe there are few tenants that, hey, we want to have our separate bus because of some compliance, regulations and security. There you can use the dedicated event bus, but in majority of the cases you may use the shared event bus. But to combine the strength of both of them, you can have this model which is called bridge model for your SaaS based apps. Let's talk about some of the best practices and key points that you can take away from this session about Event Bridge when it comes to host the multi-tenant architectures on serverless. First, use single rule per subscriber. It definitely makes easy in the rule path pattern matching if you want to make some changes. It will not impact the targets, all the targets. If it is just going to impact that target which is supposed to be impacted because you want to implement some change. If you have 5 different targets per rule, you are making changes in the routing mechanism or path pattern matching, then it may impact the other targets as well, how they are supposed to receive the message. avoid using default event bus for custom applications, for custom events. Default event bus, so event bridge has two types of event buses, like one is default and one is custom. By default, you will see, you will log on the AWS Amazon Event Bridge console, you will see the default event bus, and for custom application you need to create one. Default event bus is supposed to receive the event from AWS native services like maybe instance stopped, run instance or delete instance. These kind of API calls from CloudTrail, they will automatically get directed to default event bus. But if you are using your own business application, you should definitely use the custom event bus to not get both of these event buses mixed or events mixed. Use wildcard pattern matching wherever possible because it helps in reduction of rules and management. And when you have pool model, you are sharing the one event bus across different tenants, right? Please be aware of limits. If you are going to hit any limits or reach any limits, exceed any limits, definitely consider submitting the limit increase request, or in case if it is the hard limit, you can have separate queue as well, separate event bus as well. Key takeaways from this session, very important, it is the crux of this session that we discussed throughout the slides. One is architectural design. It is very important for the teams to spend some good amount of time to finalize which model you are going to choose for your SaaS based architectures. It is bridge, pool, silo. You need to consider all the factors because today what decision you will be making, it will be hosting your app for next couple of years or few years down the line. You should definitely externalize the data isolation from your business logic. When I said externalizing data isolation, if we talk about SQS, we talked about message attributes. It is different from the message body, right? If we talk about data isolation in terms of Lambda, use Lambda layers. If we talk about data isolation in terms of API gateway, use Lambda authorizer to generate the context related data specific to tenants. Cost optimization, use Lambda layers to get the context from the SQS queue or from the previous service, get this processed, and it will help you calculate the cost per tenant. You do not want your senders to wait, you do not want your services to wait. Process the message asynchronously wherever possible because it helps in reducing the time, and if you are reducing the processing time, eventually you are saving money. To avoid noisy neighbor, there are different mechanisms which Anand and I discussed. You can implement rate limiting, you can use Lambda reserved concurrency, you can use tier based strategy like we talked about SQS queues based upon multiple tiers. Scalability and agility. By default, serverless enables you to host your architectures without worrying about managing the infrastructure. In serverless, there is still scope of more optimization that we talked today, and you can also focus on low code services, low code integrations. Consider using event bridge pipes that where you want to process the event streaming data from different previous services, and if you can also consider using step functions, which is low or no code service to orchestrate the flow between the architectures. Cool. These are the different sessions which we would definitely recommend to you if you are into serverless community, or if you want to increase your knowledge in serverless or AWS native serverless services. You can take the picture, refer to them later. Well, how would you continue your serverless learning? You would definitely consider exploring the skill builder where our serverless experts from AWS has recorded few courses, and you can also go for these badges which are serverless as well as event and workflow. I have both these badges. I went through the skill builder courses and the content there is great. You can also go through them. How many of you use Power Tools for Lambda functions? Okay, I am seeing some hands. So, Power Tools are nothing just the opinionated library which can help you achieve the best practices in terms of observability, monitoring, if you want structured logging, distributed tracing, if you want to achieve the idempotency in your architecture by using low or very small number of coding lines, instead of you writing the whole logic yourself, you can use Power Tools. I think that's all. That's what we came up with today. Thank you again for ensuring your time. I hope you had a great session. We have given you something to think about. Anand and I will be here if you have got any questions. We'll be here for next 10-15 minutes, or maybe you can bump into us at Venetian. Thank you, everybody.